Hello and welcome back to another episode of the Oxford Online Maths Club. My name's James and this is the Maths Club. We've got some maths puzzles today. It's the last episode of this season of Maths Club. So I thought I'd finish the show with an episode made of some kind of puzzles or things to think about over the summer, things that you might try while the Maths Club is not on the air. Hi to people who are watching live. Who can I see? I've got Herb and Shrist, and there are some anonymous people here as well. Here they come now. Here they go. Anonymous people and another anonymous person. Hello everyone. Welcome to the chat. I've got a totally new Slido interface, which I'm navigating. I shouldn't have enabled it, but I think I can still do the poll. How's your day today? There we go. I like to start by asking, how's your day today on a scale from 1 star to 5 stars? Have I remembered to unmute? Yes, I have. There we go. 5 stars for me. Pretty quickly there with the 3-star people voting right in the middle there. Keen, fingers on the button, ready and Slido, ready to middle of the road. 3's not great in that poll. We will find out. Let's see. So yeah, I imagine some people have got exams. Maybe not this week because I think it's half term in some places. But maybe you've got exams next week. If you've got exams next week, good luck with your exams. Maybe this is a break from whatever maths you're doing for your exams. Probably not the maths that I want to talk about today. And maybe you've got other exams going on last week or I don't know, other stuff going on. In chat, Yukon says that today is the last one. Yeah, so we do quite a short season here. Because then I start doing the Mat live stream instead. More about that at the end of the show for what we're doing next week. Very similar show really. More of a focus on something different. We've got a 4.3 in the end, which is quite good on a How's Your Day vote. I think I'm having a 5-star day. Got those exams called A-levels, says yeah, those are mostly the ones I'm thinking about. I'm aware there's some of those going on around the place. And if I change that, then I can't see that. Oh my goodness, that's terrible. How do I make that stop? New Slido. Only new Slido for me though. I think you've still got normal Slido. Okay. So, what do? I click here. Oh, look, it's like I've never done this before. Here we are. We got chat going. We've got some maths on the screen. The stream is, as always, for this year, supported by both the Oxford Mathematics Department, where we are hosted and for some of us employed. This is home of Maths Club, but we're also supported by Jan Street. Jan Street have got some puzzles. I have picked out a couple of Jan Street puzzles and some other puzzles. Some of the particular ones I want to talk about. Shrist is worried about their mocks that they had. I guess the only thing I can say is that the mocks are not your actual exams and that the teachers don't have to base your actual predicted grades on what happens in the mocks. Yeah, okay, they don't entirely decide. Maybe they do. I don't know your school policy. Maybe your teachers are allowed to look at other stuff as well. Certainly from my point of view in a university, I don't mind whether there are any mocks or not. I just need the teachers to predict a grade based on whatever information they like. Okay, it's going to be okay. Hi, Angie as well. Look, oh, this is nice. Good. Okay, I want to show you one specific problem, very particular problem, from the Jan Street Puzzles collection. Now, I've put the Jan Street link on the stream for many weeks, so I think everyone's had a chance to have a look at the puzzles over there if they're interested. I am going to do spoilers for one of the puzzles, so if you'd prefer not to see solution to an old one of last year's Jan Street puzzles, then hey, get off the stream. Go to that website for Jan Street puzzles. Heart's content. Have a go at the puzzles. First time here. Hi, anonymous person. Hi, welcome to Maths Club. Bit of weird timing. Welcome to Maths Club. We're going to do some fun maths. But from next week, different show, same time, same place. Right. Anyway, let's get on with that fun maths. So I saw this puzzle on the Jan Street website that uses codename tiles, which look like this, and I think the puzzle is incredibly clever. I'm in awe of the puzzle construction. Mostly I want to talk about how the puzzle's designed and how it's put together. I guess we've got to talk about the actual puzzle and maybe have a go at solving it. But mostly I want to talk about how it's been put together. which is, by the way, something I'm quite interested in, a kind of puzzle design. If you're into puzzles and you like solving puzzles, then maybe you've already started thinking about how to design your own puzzles. And maybe you've already seen that when you're designing a new puzzle, that often involves a lot. I was going to say a lot more work. It's often different work or different things that you have to do. I want to explore that through this particular puzzle. Anyway, this puzzle uses cards from the game Codenames. I quite like the game Codenames, and I guess so do the people at Jan Street, because they've got this puzzle using Codenames cards. The way it works, and we're not going to play Codenames, don't panic. It's a word game. This is a maths show. I know. The way the word game works is that one player is aware of certain squares being good. It's secret. They would like to communicate that to the rest of their team, but they're only allowed to give clues in the form of a word and a number, where the number means how many of the cards are good and have something to do with that word. So for example, this clothing 9 clue means that there are 9 good words that are clothing. The game Codenames works that the person doing the clues has to think of something that links to the good words, that somehow avoids the bad words. So clothing 9 means that there are 9 words associated with clothing, and also they've had to think that that if there are any other clothing words, I should not do this sort of clue at all. Anyway, it's quite unusual to see 9, so this is clearly quite a good round of Codenames. Okay, and then they have this one, which is Animal 11. This many tiles again, and we're told that 11 good tiles of animal, something to do with animals. Okay, so that's also a pretty unusually high number for Codenames. And then this one says food 9. And the game's hard if you play the word game. I know I said I wouldn't talk about the word game, and now here's me talking about the word game. And the game's hard because often you're looking for things that are tangentially related in order to get the number up. You want to try and clue all of the good words eventually. So you might do some sort of tenuous links. You're imagining what the other person might guess. For example, they eat food in the army, so maybe that's part of it. I see army and I think, I'll say food 9, and they'll pick it as one of the 9, and I'll have communicated this good word without having to go around the kind of like military 1 or whatever route to do a separate clue. That's quite tempting, but also quite dangerous, because they also eat food in the Himalayas. But never mind. Okay, that is not what we're exploring today. The kind of weird empathy mind game stuff around the game Codenames. Here's the text from the Jan Street puzzle. They say it's the 3 best first plays for the start of the game from our recurring Codenames game night featured above. 1 match 11, other match 9, brilliant. We looked at the boards over and over again and decided that when the clues encode the target words in such a binary fashion, you can get impressive results. The answer to this puzzle is a single word. So by the way, this is a puzzle. It's got a bit of story, but it's not a real game of Codenames. It's somehow a puzzle, encoding somehow a single word. I've said encoding. I've said encoding because, well, I suppose they did. They say encode right here, look. So somehow these codename boards, with the association with like 9 of these things I've linked to with food, somehow encode a message or a word. And the way they've done that is really clever. We're going to get there. Right, okay, hi chat as well. What's going on here? We got Shrift and we got another Shrift, but only one of them is real. This is a general thing I have about chat. You can set your username to be whoever, and you should never trust that anybody's username is anything to do with who they are. It's the internet, anyone's going to pretend to be anyone. Sorry about imitation going on, if that is what's going on. Okay, right. I thought this would be easier to visualize if we kind of highlighted the correct word. So I've got these highlighters. There we go. Look, I prepared a thing. If you're new on the show, I always prepare stuff. If it's your first week here, then yeah, it's always like this. It's always super prepared. I'm so proud of myself. Right, look, and now we can highlight the ones that have got something to do with clothing. I think dress and tuxedo, but not, whoops. Dress and tuxedo, but not the other ones. I need to ungroup these. Okay. Dress and tuxedo, but not the other ones. I'm not sure about polo. Polo's a sort of sport, right? Agent and compound and deck. But then shirt and shorts, I'm happy with. Texas and cap. Plain and boot. Boot is a clothing. But then maybe, I don't like these ones. And I don't like these ones. Oh, I do like suit, I suppose. So I've got 8. So I'm missing 1, which wasn't really the plan. Oh no, we're playing code names. What did I miss? Suit, glove, cap, boot, shoe, shorts, tuxedo, dress. Those are all played. This is what it feels like to play code names. You can have a polo. Oh, polo shirts. Everyone in chat says polo. Each card has a binary state to pick or not pick. Yeah, they said binary in the text at the bottom as well. They said binary. Okay, polo. Yeah. Whoops. Okay. Thank you, chat. Thank you, Magnus. And one of the Shrishts. Yeah, polo. Good. Right, 9. Okay. So we've got some selections. Is a binary state of what's going on. Max says S, which could be a clue. Okay, right. Let's go down this one. We've got 11 animals. It is so tempting to just get chats to name 11 animals that they can see among here. I'm going to have a go as well. I think this one I hope is a little bit easier. Sharks are animals. But I think that polo being a sport and also a type of clothing is part of the fun of the word game, isn't it? It's like a lot of those English language games where things can mean 2 things. See also crosswords. I forgot in the middle of that if I was doing... This time, if I've done it wrong this time, I've done it wrong by mistake. 11 animals? What do we think? Have I got my 11 animals? I think I've got my 11 animals. Yeah, it's kind of connections, right? There's a connection. For the Codenames game, it's framed around this. Your team is trying to clue a certain collection of words overall. That one seems a bit more straightforward. And then down here, I've got some foods to find. There is such a thing as a food bank, but there is definitely food cheese. Salad pie magazine, army pedal, hamburger, Himalayas country. I think you see there's good stuff there. You can get into trouble if you need to clue sort of Himalayas and you're trying to think of other things that go with the Himalayas. If you don't plan ahead, then during the game you might find you need to say something that links together. I don't know, Himalayas and magazine or something. You find yourself racking your brain to think about mountaineering magazines, which is an interesting problem to have. Lab can mean so many things, but probably not. I have maybe deleted too many of these, haven't I? 1, 2, 3, 4, 1, 2, 3, 4, 6. Counting 9. I think I'm good. I think I'm happy. Chat is saying a lot of stuff. Oh no, that's not chat saying stuff. That is my new Slido interface. Freaking out. There we go. Hello, Imo. We're playing Connections, or are we playing Connections? We've got a puzzle to solve. The puzzle is from Jan Street, and they have shown us some codenames boards from the card game Codenames, together with this cryptic instruction. They've described the boards and given us a link to find out about codenames. They've described the board. We listed the boards over and over again, decided that when the clues encode target words in such a binary fashion, you can get impressive results. Himalayan salt. Does that get magazine though? Oh, salt is a sort of thing. Okay. Right. Okay. So that could have been a kind of food thing. If we were desperate, that could have been a food thing. But maybe it's not quite binary in the actual game of Codenames, whether things match or not. Could you call salt a food? Here we go. It's a classic Codename style argument. What do you mean salt is a sort of food? It's obviously just a mineral. You can't eat rocks. I eat rocks all the time. Okay. So you maybe noticed that the text at the bottom that goes with this puzzle goes out this way to say binary. And there are several different ways you could try and work out what to do with the binary. We've got these kind of 1s and 0s, right? 1, 0, 0, 1, 1, probably. There are several ways you could try and read this to convert this into a word, but the one that turns out to work best is if you read each row. So there's some trial and error there, which is something that I think distinguishes puzzles from something else, questions. You get these kind of binary strings. Binary is a system of using ones and zeros to represent numbers. So numbers where instead of using ones, tens, hundreds, thousands to write your numbers, you use powers of 2 instead. So that means 1, that means 2, that means 4, that means 8, that means 16. The place value is different, which is the difference there. So that's the number 19 in normal decimal notation. That's 3, and that's 18, and that's 1, and that's 2. Good. What if this was infinite dimensional? Thank you, Mac. Excellent stuff. Quick shout out to Prisma, who's moderating chat. Thank you, Prisma. It's moderated a lot of chat over time. Anyway, the reason I've converted these numbers like this is because after some trial and error, for this puzzle, that turns out to be a hidden message, which I've got over here. I was expecting a word. It's not a word, because scrab is not a word. But if you turn those numbers into letters using the English alphabet, scrab, you know, it's not the answer to my puzzle. But what I get, if I keep going down, this is the number 2, so letter B, Bulse, mod, which if I scroll out, is not a word at the end. It says Scrabble some mod, which I love so much. Oh, why are binary numbers written here again? Hi. So this was presented as a kind of puzzle. It's got the word binary in the description of the puzzle, so unrelated to the game of Codenames now, but in kind of puzzle solving world, I think someone has used binary numbers to encode a secret word as a kind of puzzle game. Nothing to do with Codenames anymore, but the text weirdly uses the word binary, so we thought about these as binary numbers, which you can turn into letters. So there's kind of 2 levels of translation there. To take this grid with the highlighted squares, to turn it to numbers via binary and then into letters. Oh my goodness. Which is something I've seen in kind of puzzle hunt competitions before, or the sort of translation between different ways of encoding data to have some complicated grid or something that you look at it in the right direction and it turns out to be a bunch of ones and zeros, and then you think, this might be binary, I should put it through, and the binary comes back and it says beep, beep, dip, beep, beep, and you think, that's Morse code, and then you feed it through something else. Yeah, so they've got a message going. They can spell a lot of words. Yeah, they can spell a lot of words. And I guess setting this up is kind of cool, because for the game of Codenames, it doesn't really matter where the cards are, but then for Jan Street to encode some secret information, they can do their secret information by moving the cards around so that they spell Scrabble some odd in the positions of the cards. That's kind of nice. And the game Codenames is about secret agents meeting and sharing secret information, so this is a different way of putting secret information into the positions of the grid. Anyway, this message is maybe not what I was expecting. This message says Scrabble some odd. Yeah, or maybe it says crabs. That'd be nice. Or carbs. But it keeps going across these 3 boards, which are presented in this order. Ignore on the right, where I've got on the right, I've prepared, just in case I forget what food is, I've prepared a grid beforehand. Did I get it right? Yeah, here's one I prepared earlier. Yep, good, I do know what food is. You never leave anything to chance. Technically, couldn't the number in the clue just be the binary value of which numbers are valid? Yeah, it tells you which card to choose. Ooh. Ah, yeah, okay, like I like this. So this is codenames cheating advice, which I love. Let's talk about that. Forget the Jan Street puzzle for a moment. In the game Codenames, you're allowed to choose the word, which is supposed to be related to the words, and you choose a number. And the suggestion in chat from an anonymous person, secret identity, just like in Codenames, protected their identity, and they've got a great idea, which is to convert which numbers are valid, converted into like hex or converted to hex or the deanery for base 10. Okay, so take which cards are good, convert them to a massive number, and then say octopus 37 or something to mean convert 37 to binary, a code that we've agreed beforehand. In my opinion, the rules of Codenames are unfairly harsh on people like you and also people like me who want to have some fun with the number. So they try to ban having any fun at all with messing around with what your clue actually means. In a tight spot, I tried to clue the word octopus by using the number 8. This was deemed not allowed. The rules don't permit it, which is annoying. I think it'd be more fun. Here you go, super anonymous. I don't even know if you're the same person as the one 2 down. I've seen both actually, deanery and decimal, I guess. Deanery feels nice because it sounds the same as binary. It makes it more clear that those are similar concepts. Decimal would be bisimal. Quick check. I guess not bisimal because it's dec from 10 for decimal. So it'd have to be bimal, which nobody says. Nobody says bimal, except me. I do now. That's just one of those things I say like shine. Right, good. Okay. I don't think anybody in chat has told me, except for Mac, who keeps saying crabs, probably because this is an anagram of crabs, right? I don't think anyone is quite on board with the next level nature of this binary encoding. Whereas I would normally expect the puzzle to be done now, that the puzzle would encode a word like that, with the idea of looking at binary. What it actually does is it says Scrabble sum odd. That's not a word. We're looking for a word, a single word for the answer to this puzzle. And this says Scrabble sum odd. Do people in chat know what Scrabble is? I think we probably know what Scrabble is. Could you encode horizontally? Yeah, so you could do. I've read along the rows for my binary numbers, but I don't know whether Jan Street. We're actually thinking about going in columns instead. And if you do that, you get different numbers that, as far as I can tell, don't mean anything. It's just nice that if you read each row as a number, they correspond to numbers between 1 and 26, which I can turn into letters to spell Scrabble sum odd. I mean, that's what we've got. The thing they want you to do next for the puzzle, which is really, I think, not obvious, is to go back to the words and read them again, but this time, instead of highlighting the ones that are good for code names, to highlight the ones that are good for Scrabble, in the sense of having an odd Scrabble sum. So you can imagine going back and instead of highlighting the ones that are good for code names, to highlight the ones that are good for Scrabble, with an odd score in Scrabble. So in Scrabble, all the letters have these values. It's a different game where all the letters have values, and you could imagine adding together. I've picked 2 with, okay, Q is worth 10. Possibly B is worth something like 3 or something like that. You could go back through and add up all the values of each word and check which ones have an odd value. Yeah, Scrabble piece. Magnus is so close. Yeah, I don't know, it was like half pieces. So each one's got a word on it, so we're doing something with a word. If you do that, so clear that out. If you do that, then you get this. So I need to remove all of this. That was our first plan of converting the numbers. if you do that, you get something like this. For a different way of highlighting the cards, same picture, different highlighting. For the ones that have an odd Scrabble sum, which, I mean, probably involves looking up how Scrabble works, looking up the scores in Scrabble, and then, oh my goodness, adding up the values of each word. So you go to tuxedo, and you're like, X is worth 8, 1, oh, that's even, so it doesn't get highlighted. If you do that and you convert them to binary again, you get a new message. So this is now nothing to do with the codenames part of this, or how the game codenames works. This is now looking at the words again to see which ones are worth an odd number of points in the game Scrabble. You get this kind of highlighted thing, which I quite like. I thought maybe this one would be like, I don't know. So this looks like a kind of smiley, swoopy face. It could be like some sort of character from a different alphabet. And this one looks like, I don't know, a hill. This one looks quite a lot like the character from the game Among Us, but never mind. But in fact, if you read it in the same way as before, so if you read it in the same way as before by converting each row to a binary number again, then it spells a new message. The new message is longy are than 5 blank. So that's a whole thing as well. I already think this is mad, that it's the same image, it's the same photo of the codenames board, but it encodes, if you read it as a codenames board, with like words that match the codename clue, it tells you one message, and if you read it with which ones are worth odd or even numbers of points in Scrabble, then it gives you a second message. I think that's really nice. Here we go again. Anonymous says, short Minecraft sword. Yeah, I should maybe go with that. Highlight the ones with length more than 5, right? Because it says longer than 5. So we should do it again. This is kind of hinted in the clue where it says, we looked at the boards over and over again. Never mind. Okay. So that can go over here. So if you do that, if you highlight the ones with more than 5 letters, you get this grid. Same picture, same codenames boards, and same way of translating. So once you select the ones that are longer words, so not dress, that's exactly 5, and not agent, that's 5. Boot and dash and kiss are short words. If you highlight those and convert them through binary as well, now you're into the swing of things, and you get the final message: middle letter of blank. So we have these 3 messages now: Scrabble sum odd blank, longer than 5 blank, middle letter of blank. Yeah, there's anonymous. That's what I want to talk about. We're going to get to a solution or something. I just want to see if chat can finish this off, to be honest. Get to a solution, but then I want to talk about how this is constructed. Because yeah, come on, this is mad. Okay, so again, we've got some highlighted ones that say those are the ones with more than 5 letters in. You highlight them and it spells middle letter of. Now, has chat got any idea what we might do with middle letter of? Because it's not a selection, it's not a binary selection anymore. This is the last message that the thing gives us. We're looking to chat. Ones with the middle letter of the clue in their word. Oh, the middle letter of the clue. Oh, that would be binary, right? Hey, that's a great idea. So for clothing, the middle letter, clothing's got 8 letters, but I like that a lot. We would go back to code names, take the middle letter of the clue, and then look to see so O's and I's and M's and T's or something, and do another binary round. That's fair enough. Matthew wants to concatenate the middle letter of the words, middle letter of each line. Oh, middle letter of each line would be great. The problem is you've got these even lettered things like deck. I haven't counted across the whole line. There's actually a part of the puzzle that we haven't really used yet, in a way. Let me intersect all of these together, just because it looks good. There we go, okay. Do the intersection. Nice. Is it coming up properly that... it's a little bit subtle that things like deck is a slightly different colour from plain. Oh no, they're both pink. What am I talking about? Where's a triple intersection one? Is that a triple? That's a triple. Yeah, so shorts is a kind of slightly different colour from skyscraper. Only just maybe. You know, brownish and purplish. Okay. That triple intersection. There's part of this puzzle we haven't really used yet. I want to see if Jack can find it. Find the middle letter of which row. Concatenating middle letter of unhighlighted words. Yeah, so unhighlighted words is quite a lot, but there's some in particular that we want to use. It's, yeah. Trish, the real one, as the distinction actually matters, wants to look down at the final row. The final row is the bit that hasn't been highlighted at all yet, somehow, despite all of the different ways of looking at the grid. This one has got words down here, each of which has an odd number of letters. So maybe we could take the middle letter of these ones. And also I accept like also cycle and bride, but not banks. That's a bit confusing. But you can take the middle letters of these words to get S-I-E-V-E, which spells sieve, which is a word, and it was all right there all along. Isn't that amazing? Isn't that great? Isn't that... I don't do a lot of like this kind of puzzles where you have to find the puzzle. So maybe this is what they're all like. It's not something I do a huge number of, but I really enjoyed this one. Sieve, 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 says chat. Sieve, 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 which is also what we're doing, right? I mean, sieving out the answers. I want to talk about how this puzzle is built, because building puzzles is just a completely different task, right? So the person building this, let's try and imagine what they had to do. I've got a Venn diagram somewhere. Here it is. So they had to find, I guess, if you've decided that these are the categories, right, of ways to encode binary information in codenames tiles, so codenames cards, and there's the kind of obvious one that the ones that go together with the codenames clues, and you get some flexibility. And then you have Scrabble some odd, which is kind of pseudo-random. So that's quite good, because you don't really want these to be correlated together. You're trying to show particular information to encode these messages, and you want those to be kind of separate messages with nothing linking them together really. So you kind of want these to be uncorrelated in a way. It'd be a real problem if there was nothing in here in the intersection, because some of these things are supposed to be, well, I guess orange for the intersection colour there. Some of these things are supposed to be orange, like pie and pizza. In this row just need to be like that. And then you kind of have a little bit of flexibility, but not really, over here, about whether the words are long or not, I think. Oh, how do you spell flexibility? There we go. That's suspiciously many I's. I'm not sure about that. I'll keep it really small so no one can see my typos. You have almost no flexibility on how that's built, but you can't really change the number 5 because you need the messages to be a particular length if you've already decided that the final answer is going to be in the last row that you haven't used. So there's not much flexibility there. So then you're kind of at the mercy of what's actually printed on codenames cards, I think, to try and work out what stuff's in here and here and here and here. And then I guess you've got to play codenames a bit to try and find some matches between the words that you're planning to use. You've got a bunch of words that are Scrabble some odd, but not longer than 5. People think, well, hang on, there's quite a lot of food words in here. Maybe we can use that as the category and then arrange them. Oh my goodness. You've got particular spaces where you need a word that is, looking at this circle over here, let's put a circle around circle. Looking over here, you need a word that's more than 5 letters. A card to go here that's more than 5 letters, is not an animal, and is worth an even number of points in Scrabble. And that's quite restrictive. You've got some flexibility to move the cards around, I guess. But in a way, what you're trying to do is build this from the top down, to have the colourful highlighters first and then fill in the cards, which is almost entirely a different problem. It's so cool. Mac agrees with Imo. I can't remember what Imo said. Yeah, cool, good. Okay, I think this is lovely. Along the way, you've got to do a little bit of guesswork when you're solving it to work out that the binary goes sideways and that you're supposed to convert it to a message. So when you're actually solving it, there's some steps that are a little bit tricky, but it must have felt so good to invent this. To have that kind of clear idea of like different ways of encoding binary information in a grid of cards. Because that's kind of what you're doing in Codenames. It's what the anonymous person in chat with the plan of how to perfectly encode the binary information in that grid with a single number. It's what they're doing. They're encoding binary information and other ways that you might, or other sorts of binary information you might try to hide in the same grid. I think this is brilliant. If you're trying to design a puzzle like this where you reuse the same component, then I think you need to think about different aspects of the component that probably need to overlap in uncorrelated ways so that you can possibly stand a chance of storing two bits of information that are totally separate. So you probably need some categories or some characteristics where there's some overlap, some of each, and some of neither. Those words at the bottom are all short words with a middle letter that are worth an even number of points in Scrabble and that have a Codenames card and didn't fit into the category they wanted to use for that collection. Yeah, so Civ does feel like another clue. Maybe there's another level. Maybe we're missing something. I should keep going. I have based this closely on the solution that they posted. For puzzles in the archive, they have solutions up. Okay, how are we doing for time? Ooh, that went for longer than I thought, but it's worth it. Look at this. Okay, I guess the call to action here is, if you think that's cool, then there are several puzzles at Jan Street. They put a new one up every month. I hope they don't mind me saying this. Some of them are in a series where there's a style of puzzle and they explain all the rules and you do that puzzle. And some of them are not that at all. And I hope they don't mind me saying that. I prefer the ones where they don't tell you all the rules, the kind of puzzle hunt kind of ones where you've got to work out what the puzzle is as well. Good. Anyway, here's this thing where you've got these grids of digits to fill in as well. They've got a couple of those if you want to see one of those. Two. Good. Right. Okay. Call to action. What was I going to do next? I was going to show you more puzzles, I think. That's the plan for today. It's summer puzzles. There's one where we solved it now. I want to describe this one without solving it, so no spoilers. And this one is also from the Jan Street website. It uses some A-level maths ideas, and possibly in quite an advanced way. So if you're not at A-level or equivalent yet, then this puzzle is still fun to think about. Actually calculating it, oh my goodness, this has calculated 10 decimal places. Calculating it probably needs some techniques from A-level that you need to be quite familiar with. Okay, so it's a game for two robots, but it's kind of more than that. There's a layer wrapped around that. So we've got two robots playing a game. I think they're robots because they're following instructions and they're, in theory you could understand them. They follow their instructions perfectly. They're reliable and predictable in some sense. Anyway, which matters because there's information going around here. So they're in a circle, and they start at the middle of the circle. Okay, in you go, both of them. And a flag is placed somewhere. One of the robots, Aaron, is able to deduce the distance to the flag. I can see that it's on some circle, but they don't know the direction. Excuse me, let's try and draw an actual circle. That'd be good, wouldn't it? Oh, everything's gone a bit wobbly. Ah no, we're good. Let's try and draw an actual circle. Okay. Hold shift for circle. I guess if I can't move that circle, there we go. That's good enough. Okay, they're told the distance to the flag. Perfect diagram, no notes. Aaron's told the direction to the flag, so which direction it's in. Oh, I guess this is a mistake. This was a mistake. That way. Both robots are allowed to make a single move, so they can go anywhere. They should probably go in the circle because they're trying to be close to the flag. Any move they make is without the knowledge of what the other robot's doing. I can't move outside the circle. Whichever robot is closer to the flag after these moves captures the flag and is the winner. But then there's this kind of wrap up. So there's already a problem there, right? One of the robots only knows the distance. The pink one only knows the distance. So maybe they should jump to somewhere on the circle, right? Because then they have a chance of being exactly right. But maybe if they're unlucky and around the other side, then that's quite bad. So maybe they should actually jump a little bit inside, so that there's some region where it would be a good guess, but it's not too bad if it's around the other side. So already there's a question there of what should you do if you know the flag is somewhere on this circle, but you don't know how far to jump. You don't know if you should jump all the way and risk being really far away from the other side, or even or jump a little bit less far to be somewhere inside. I'm moving the flag, which is not part of the game. There we go. Flag. Pink arrow. Flag. Okay. Yeah, it counts as a revision, right? If you know some A-level maths, then you maybe know that you could do some sort of integration for the kind of probability density function for where the flag is. From Aaron's point of view, Aaron knows the distance. And from Aaron's point of view, if Aaron is at some position and the flag is somewhere on the circle, equally likely from Aaron's point of view, uniform around that circle. Uniform, I guess the flag is maybe or maybe not uniform around that circle. Then there's some integral you can do, which depends on distance or something, for Aaron's expected distance. Okay, separately, that's all Aaron. Separately, Aaron knows the direction, and Aaron's got a choice. How far along that line should I jump? Maybe halfway, because the flag could be anywhere between here and the outside. Or maybe a bit further, because the outside of the circle is bigger. The flag's somewhere in the circle chosen uniformly at random around the circle. The outside ring of the circle, like the outside ring of a darts board, is bigger than the inside rings of the bullseye of a darts board. So maybe Aaron should go further out, because more likely to be further out. We know the direction, but not the distance. Maybe we should go further out. That's also a kind of probability question for what's the average distance of a point inside a circle from the middle, which is something that you can calculate using A-level stuff. Is it uncertainty? Yeah, between them, weirdly, they know where the flag is, but neither of them knows. Yeah, both. Thank you, Brian. That was excellent. Okay, here's the wrapper that I mentioned around that game. So we've just got these kind of A-level probability questions. They're in a competition, of course. They're not just trying to minimise their distance to the flag, which I suppose is the main thing that it can do, but they are also competing to be the closest, which maybe matters. Anyway, during the preliminaries, it's discovered that Erin plays a fixed distance along that line. Assuming otherwise optimal play by both robots, can you determine the probability that Aaron will win? And can you determine, I suppose, what Erin is doing? Erin is doing optimal play, I suppose, to jump the right distance along that line. So this is kind of idea about optimal play. And there's something maybe to look up called a Nash equilibrium, if you're interested in this sort of thing, where you're playing a game and you would like to play. You're playing a game, there are other players, and you're not working together, but you know that they're rational and that they're trying to maximize their chance of winning. There's something called a Nash equilibrium, which is a way to understand what will actually happen in terms of them trying to maximize their probability while you maximize yours, and you're both aware of the other doing that rationally and with full information of the problem. There's a way to do that where you can analyze the problem like that. It sounds like that should be an infinite recursion, right? But I am considering a move, but I have to remember that you know my move. You know that I'm rational, so maybe you'll do something different because you know I'm rational. But on the other hand, I know that, so maybe I should think about what you're doing, but then you'll think about that, and I'll think about that, and backwards and forwards. And you're trying to outthink each other, but actually I've got to make a move. that doesn't come into it because it kind of all balances out in the end. There's some information here, yes. In the end, it turns out that, I suppose, if you're acting rationally, there's a way this ends up where it doesn't matter if you then announce what you're going to do. If there's a unique Nash equilibrium and you're rational, then both players will work it out. So it sort of doesn't matter that even if you announce what you're going to do, that doesn't change what the other person does, because they could have worked out that you were going to do that anyway. You don't really have a choice if you're trying to maximize your probability. It's weird. Maybe this is why they're robots. To sort of do this kind of like maximizing, I'm a robot and I know that my opponent is a robot as well. Anyway, I like to say that Nash equilibrium is a way to sort of do calculated empathy, that you try to imagine what it would be like to be the other person, but very precisely, with a very particular model of how their mind works. So part of the challenge of problems like this is to imagine what's going on in someone else's mind. Maybe Nash equilibriums are the way to do that. Okay, now I'm just mentioning things now, I think, to see if anybody's interested in them. I'm going to move on. Project Euler. I'm a bit worried that I haven't mentioned Project Euler enough over this season of Maths Club. Maybe I should have been mentioning it every week. Hey, have you heard of Project Euler? The idea is that it's maths problems that you do with the help of a computer. Not always, but almost always with the help of a computer. Here's an example of one of those problems, which you could choose whether you want to use a computer for or not. It's an observation that 49 over 98 is equal to 4 over 8, which is silly because it looks like you've cancelled the 9s. But it's true. It's a bit of a weird way to write either of those fractions because they're both 1/2. But it works. And the question works like this. The question says there are other examples of these with a less than 1 value, so smaller number on the top, containing 2 digits, numerator and denominator. And then they usually ask you for a kind of single number calculation at the end, which is not super interesting to us because that's just so that you can submit a single number at the end as your answer. I think there's something going on here for you to investigate. It's the sort of puzzle where you can get started with a pen and paper, and then maybe it turns into something where you want help from a computer and you need to write some for loops or something like that. But I think there's something going on here. For example, you might try and bring some algebra in, right? Ben asks, have I ever played the natural number game? Yes, Ben. I've played it on stream. Not this one. But on my Twitch stream, twitch.tv/James Munro, we played the natural number game a couple of weeks ago. We played it until it broke. Then we stopped playing it. We did not prove Fermat's last theorem. Stretch goal for the stream. The video of that is buried somewhere on, oh gosh, I think it's probably on my YouTube channel. Good luck, Ben. Natural number's really fun. Natural number game's really fun. You have to prove facts about natural numbers using proof operations. The actions that you do in the game are all logical deduction, and you have to do them in the right sequence in order to prove a theorem. It's a good concept. Trivial and non-trivial. So trivial, synonyms of trivial are kind of like obvious, sometimes a little bit more judgmental, like not interesting. So then non-trivial means not obvious, or not interesting. And not interesting is the same thing as interesting. Law of excluded middle. Such a good game. Anyway, so maybe you want to bring some algebra in, and then it's possible to sort of mess around with this, where then the b's cross out, so then it will be equal to both a over c, and then you have to like rearrange it and see what happens. I don't know. There's something to be done there, I think. Before you get out a computer and just tell it to try. I don't know what would I do with the computer. I do like for I is 1 to 99, for j is 1 to 99. Oh no. And just sort of think about each number on the way through. Good. Okay, if you want other puzzles like this, Project Euler has got thousands of these. They get harder by index number. So this is problem 33. There are thousands of these. If you go to the archives, that's a good place to find puzzles. Oh gosh, yeah, Mac is off and away with the robots. I think I like curious fractions. Oh, like this. There's probably some 3-digit ones. This question wants 2-digit ones. There's probably 3-digit examples, or if not, then that's also interesting. So a 3-digit example would be something like, I don't know, 213 divided by 361 being exactly equal to 23 over 36. It's not, but imagine if it was. Wouldn't that be weird? I've managed to make that sound less interesting than it is. Good. Ben's found a YouTube video. What are the chances? Oh no, that's Herb. Herb's found a YouTube video. What are the chances that that is a video that I should watch? It is me playing the natural number game. Thank you. Well done. Brian says UKMT Math Summer School. Yeah, that's the thing. I'm also worried I haven't mentioned Chalk Dust enough on the live stream. We're in a bucket list now. Chalk Dust is a magazine. It has articles about lots of different sorts of maths, and always a nice cover image. Some information about kind of university level maths written by university students, but in a way that's quite easy to follow and has lots of pictures and nice introduction and stuff. They add lots of jokes and joke articles. They also have, because we're doing puzzles today, they also have a prize cross number. Ooh, so cross number is like a crossword, but instead of words, who needs words? All the answers are numbers, and you might have clues that give you some clues to what the number might be, and then piecing it all together gives you some sort of number overall. Love Chalk Dust, big fan. On the left is issue 19, which has just come out. My tagline, not AI generated. There you go. So new articles. I've got a big box of them under my desk, but the actual thing is also on their website, which, professional, I have cropped off the end. There you go. Their website, which is chalkdustmagazine.com. I think it's one of those websites where you don't type www, but if you search for Chalk Dust Magazine, then you should find this. I'm just saying because they've got almost 20 issues out now, where, at the very least, if you do the price cross numbers, you could look at the articles. You might just discover your next favourite sort of mathematics. Right. What have I spotted? Secrets of Pascal's triangle. Long term people will remember we've done Secrets of Pascal's triangle probably too much on the Maths Club. Possibly too much of that entirely. Right, where's my thing that tells me what's going on? That's the thing that tells me what's going on. Okay, it is for some reason 20 minutes behind schedule, but that's all right. We can't all be on schedule. Okay. I promise I've done this before and I know what I'm doing. Okay, let's do a quick wrap up. We've seen various puzzles, various suggestions for things that you might do over the summer. At least 3 sources of puzzles there. Let's put them together. Where you saw the Jan Street puzzle website, where they have their own form of cross numbers and esoteric, slightly weird things. Solutions for almost all of those are on their website too. So if you just want to see some stuff and marvel at the way the puzzle is constructed, like me, marveling at the way this one is constructed, then you can check out their website. They're also doing summer schools and things. We have Robot Catch Flag Project Euler for stuff that you might need help from a computer with. Chalk Dust for a bit of fun, as well as some articles on mathematics. And I also want to finish by sort of plugging the collection of what we've done this term. Pull it in slightly and then out again because I didn't leave a gap. The collection of what we've done this term, because between the episodes I think we've covered quite a lot of different sorts of mathematics. Suggestion for doing UKMT problems. UKMT problems are a good source of extra maths challenge. Sorry, yes, that's what was going on. Yeah, people who came to the open day. Sorry, I'm catching up with chat. People who came to the open day. Yeah, we gave you some chalk dusts that we had. Good. Ira in chat asked about Mac livestream, so let's do the ad for that now. So from next week, that's the worst. What have I done? I should maybe have prepared this. The Mac livestream starts next week. The idea behind the Mac livestream is that we look at Mac questions, starting with some revision material, covering basically A-level mathematics, the first half of A-level mathematics. But the revision material includes warm-up material and stuff to help you transition between A-level questions on the one hand to Mac questions on the other hand. Along the way, there's some Mac questions in there as well, with hints and worked solutions. We're doing live streams on them, as we have done for the last few years. That's going to start in this slot next Thursday. So 5 o'clock, I'm looking forward to it. We're going to do an episode about polynomials. The stream is scheduled on this channel. If you're subscribed to this channel, you don't have to go anywhere. It will just turn up. It's free, no registration required. And even if you're not doing the maths admissions test, then you're welcome to hang out and revise some A-level maths with us. Maybe learn some extra things as well. That is going to be taking place on this channel in this time slot. E to the theta of place on the E. Max doing the robot. Sorry, I remembered. Max doing the robot question. Yeah. Yeah, you've got a factor for which direction you're going in. Okay, a quick revision of what you can see on the Maths Club page. This is just the ones we've done in 2024. We have had special guests on the show. We have had special guests talking about things like music and mathematics. We've had maths and the law. Where's that? There it is. We've had guests on the stream to talk about proof by story, where you have some mathematics and you want to explain what's going on by telling a story. So that was Maria and Coralie and Eve. Sophie was on to using colour to prove mathematical statements. And of course we had Miles on for geometry. That one's worth going to just for the visuals that Miles made with kind of train lines disappearing off to a vanishing point at infinity and different things happening in 3D. If you've wondered what an enormous parabola would look like, so a really big parabola drawn on the ground and then viewed with perspective, that's the stream where you can find out what a really big parabola would look like. I'm not forgetting other external to Oxford guests. Oh, I'm going to do this in a terrible order. It's going to be terrible ordering. We have Matt Parker on the show to talk about leap years. If you've ever wondered why leap years happen when they do, then Matt Parker came on the show to tell us about that back in February the 29th. We have had, oh gosh, which other ones have guests? Why have I done it like this? I'm going to mix up the thumbnails, but at some point we've had guests like Alice recently. There's Alice. Alice has been on the show twice to talk about maths and computer science and topology. When they go together quite well with ones on graph theory from the previous year. So we had Leo on the show to talk about friendship paradox. That's the thing about your friends having more friends than you do. It's kind of linked together. We're always looking for links between mathematics ideas. Let's not forget other ones. I feel like I've got to list all the guests now to promote absolutely everything. I'm not going to miss anyone out. We had Eric on the show talking about Hall's marriage theorem. So Eric demonstrated a kind of card magic trick that always works. And the proof that it always works uses something called Hall's marriage theorem. Yes, I am not forgetting that Leo came back and did mathematical biology. That was not something I've forgotten. And there's a bunch of episodes where I've talked about numbers and division algorithms, the golden ratio semi-recently, puzzles and hyperbolic geometry. That is 20 episodes that we've done just this year. Maths Club's been running for several years now, so we have, I think, roughly 100 of these. If you want to watch other episodes from previous years, they're all available on this YouTube channel in this playlist, if you found us through the playlist. And on the Maths Club page, homepage for the Maths Club is on the bottom left of the screen right now. I hope you find some maths to do over the summer. And Trish's got a math question. There are no statistics or mechanics problems on the mat. Because there's no statistics or mechanics on the syllabus for the mat, which is what we're going to cover. For 8 weeks, we're going to look at every topic that is on the mat, on the mat syllabus of the list of A-level topics. And it doesn't include stats and mechanics. Tiny bit of probability, but just a tiny bit. We'll get there. Don't worry about the probability. We will get there. How many? Maybe Emo is actually asking how many mat live stream episodes there are. So we're going to do a first batch of 8 to do revision material for all of the mat syllabus topics. That'll be 8 coming up in the future. After that, we'll get to summer. I need to plan what I'm doing on my summer. There's a big bunch of to be confirmed, which we will see. Okay, I think I'm going to call it there on the Maths Club. It's been really fun doing fun maths over the last 22 weeks or whatever it is for different bits of maths from so many different angles, so many different points of view. And I don't just mean the perspective, but different points of view on what you can do with mathematics and what's involved in solving maths problems and different strategies. I think we've really seen different strategies of approaching problems through the different topics of episodes this year. Quick details. So people have got quick questions. Imo says thanks for the season. So yeah, thanks for joining in with this season of the Maths Club. I'm going to do quick questions. Further reading. I've got really behind with the further reading. The last 6 episodes are missing further reading. My plan is now that if I get spare time when I'm not doing that live stream things, then I might come back and add in further reading. I do owe you 6 weeks of further reading, especially on the things from Alice's week, where we have things that I'm supposed to tell you following up from Alice's Computer Science Topology weeks. So at some point, maybe I will add further reading notes. I know I'm saying this on camera, so it's recorded forever. And please don't cry. We're not really going anywhere. There'll be more of that. 2025 admissions MAT exam details. So MAT this year. The plan is to do announcements about details very soon. MAT livestream will have all of the details, and of course the MAT web page will be updated with details when we're ready to announce them, which I'm expecting to be very soon. Because I'm starting the MAT live stream very soon. First worksheet is up already. If you would like to see polynomials and some revision material on polynomials, you're probably doing that already for your exams next week. But if you want to revise polynomials with us next week, I will see you on the MAT live stream for that. Some MAT questions on polynomials as well. Otherwise, I'll see you, I suppose, maybe next year in January for more of this. I'm not going to work out how many hours that is, so I think instead I'll say thanks for watching. I will see you again in 167 hours for the first episode of the MAT live stream. Take care everyone, have a good evening, bye.